A very good day to Professor Sophie. My name is Daniel Alexander and we'll be presenting this video vignette based on question number 2 among the 8 given questions, which is to comment on R outputs. The content of this video will be separated into 3 sections as such. This section will focus on testing the hypothesis with decision rule using the p-values calculated using both brute force and the pre-programmed command. The null hypothesis for both is that the mean prices for Microsoft is 0, while the alternative hypothesis is that mean for prices is not 0. The brute force method involves a 2-step process. Firstly, t-statistic is calculated via dividing the coefficient of Microsoft, Starbucks, and SP500 with each of their standard errors. Secondly, the brute force calculation allows decision to reject or failing to reject the null hypothesis via the absolute t-statistic value greater than the two-sided 5% critical values or using the two-sided p-values. Both calculations reject the null hypothesis that the mean prices for Microsoft is 0. The former shows that the absolute t-stats for each asset's value is greater than the critical value of 1.984 shown to be true. The latter shows that the p-value for each asset is smaller than the 5%. Hence, all this suggests that the null hypothesis is rejected. The pre-program method is more straightforward than the brute force as seen from the one sample t-test, as the p-value appears to be less than 5% for Microsoft, with the mean for prices being 0.02754 and with the confidence interval between 0.006354 and 0.048729, hence rejecting the null hypothesis of mean prices equal to 0. This section involves commenting the OLS estimation of Microsoft with SP500 being the only explanatory variable. The graph shows the difference in slope between the least square feet and that of direct relationship for returns between Microsoft and SP500, with alpha being 0 and beta being 1. Hence, both will significantly affect the estimation, with the least square feet helps to better estimate the relationship. The residuals is summarized into 5-number summary and can be translated into a box and whisker plot as shown. The coefficient section allows us to estimate the regression model for Microsoft as shown. As the p-value for SP500 as explanatory variable is less than 5%, it is significant enough to be included in the model. The residual standard error around the fitted model can be observed as such. The R-squared shows that SP500 as a predictor explains about 38.63% of the variation in Microsoft return, while the adjusted R-squared shows that SP500 as a predictor explains about 37.58% of the variation in reality affecting Microsoft return. This interpretation would not significantly affect the fitted model in this case, as there is only one single explanatory variable. Since the p-value is less than 5%, it shows that the model is performing well. The 95% confidence interval of 1.135 to 2.259 means that it is 95% confident that the true slope of the regression line is in the range defined by 1.697 plus minus 0.5616. Next, we will explore if the residuals violate the Gauss-Markov assumptions in justifying the use of the linear regression model for inference. The residuals scatter randomly around 0 over time, meaning the errors have 0 mean and that on average the regression line should be correct. This fulfills the first assumption of Gauss-Markov. The histogram, box and whisker plot, density curve, and normal QQ plot show that the residuals are normally distributed with 0 autocorrelation and homoscedastic. This fulfills the second and third assumption of Gauss-Markov. The sample ACF did not indicate any bar of each leg going beyond the dashed line of 5% significance limit, suggesting that there is insignificant autocorrelation in Microsoft residuals, and hence the residuals of Microsoft and SP500 are statistically independent. This fulfills the fourth Gauss-Markov assumption. In conclusion, as none of the assumptions are violated, it ensures that the OLS estimator for Microsoft is the best linear, unbiased estimator. This section shows the average result of the 4 assets portfolio as response variable against SP500 as the explanatory variables. The residuals show that the distribution is much compact, concentrating within a smaller interquartile range of about 0.08 as compared to an analysis on Microsoft. The coefficient allows us to estimate the regression model for the portfolio. As the p-value for SP500 is less than 5%, it is significant enough to be included in the model. The residual standard error around the fitted model can be observed as such. Since it is still a single independent variable model, both R-squared and adjusted R-squared could be used. The R-squared and adjusted R-squared show that SP500 explains about 49% and 48% of the variation in the portfolio respectively. Since the p-value is less than 5%, it shows that the model is performing well. Change in asset return for Boeing and Starbucks, while a change in SP500 is lower than that of Microsoft and Nordstrom as the estimate is smaller. The effect for the return in asset has been averaged out in the portfolio as shown with estimate of 1.128. The smaller R-squared of Boeing and Starbucks means that SP500 as an explanatory variable does not explain as much of the variation as compared to the R-squared of Microsoft and Nordstrom. The portfolio in general has a higher R-squared as compared to the other individual asset, with SP500 as an explanatory variable, which explains about 49% of the variation for the return in asset for the portfolio.